Okay, part 2 of the video is going to continue looking at our parent functions, and this parent function is the square root function. So some key features, and right now I need you to fix a typo. This should be x minus h under parentheses. So our expanded form from our parent is f of x is equal to a times the square root of x minus h plus k. Little typo in there. You should probably take some time to fix your reference sheet also. So the x and the y intercept of the parent function are at 0, 0. And this is a unique function in the fact that it only exists in quadrant 1. It starts here at 0, 0 and curves upward this way. Now that should make sense because we can't put in a negative number under the square root. So some key reference points of our parent, if we look at a table of values, if we put 0 in, we get 0 out. If I put 1 in, the square root of 1 is 1. If I put 4 in, square root of 4 is 2. And if I put 9 in, the square root of 9 is 3. And if we look at our graph, we have 0, 0. If we put 1 in, we get 1 out. If I put 4 in, I get 2 out. If I put 9 in, you can see I'm approaching 3, and that's where we get this gentle graph. Now, much the way that we've seen a parabola behave, A is going to control our direction, whether it opens the direction it does, positive A, it's going to curve up this way. If A is negative, it reflects over the x-axis and is down in quadrant 4 here. A also controls the growth, and if A is a fraction, something between 1 and 0, that is a slower growth. If A is some number bigger than 1, that's going to make that fast growth. It's going to increase how quickly our numbers get. Now, this is our typo area. If under that square root sign, we have x minus h, we are going to move right h units, just like we saw with the parabola. If it says x plus h, we are going to move left h units. K is going to be our up and down movement. So a positive k, we go up that many units. A negative k, we'll move down that many units. The absolute value function makes this unique V. It is a V, it's not curved like a parabola, so it is distinct from the parabola. I always remember the shape of this graph because it's a V for absolute value and the graph looks like a V. Again, we've got a typo here, so go ahead and change this to minus. So our expanded form from our parent is f of x is equal to a times the absolute value of x minus h plus k. So our parent x and y intercepts are at 0, 0. Our base graph always starts right there. If we think about some reference points for our parent graph, if we put 0 in, we get 0 out. If we put 1 in, we get 1 out. If I put negative 1 in, I get positive 1 out. 2 gives me 2. Negative 2 gives me positive 2. And so you can see this shape emerging at 1, 1, at negative 1, 1, at 2, 2, at negative 2, 2. So we have this line of symmetry on the axis, very similar to a parabola. So as you would expect, our A, H, and K are going to do their consistent jobs, where A is going to be direction and rate of growth. So a positive A is going to have us opening up. A negative A will have us opening down. If A is that fraction between 1 and 0, we have a slow rate of growth compared to our parent. If A is something greater than 1, it's going to grow more quickly. It's going to be steeper. H, again, if we have x minus h, if you fix that, we are going to move right h units. If we have x plus h, we're going to go left h units. And k does what k always does, a positive k, we're going up k units, and a negative k, we're moving down k units. Our last parent that we're going to look at is the cubic. So the cubic graphs are kind of interesting. So f of x equals x cubed. Now remember, the exponent tells us how many potential zeros, how many potential solutions, how many times it might cross the x-axis. So there could be 3 solutions up to. Now there could be 0, there could be 1, or there could be 2, or there could be 3. Sometimes the cubic graph gets a bigger bend in it, and you start to see things like that where you would have 1, 2, 3 solutions. Sometimes that little bend takes place above or below, and then we just get 1. So some different sorts of shapes can start happening with the cubic, but for us, this is the parent. So some key features, we've got f of x is equal to a times x minus h cubed plus k. And again, we see that x minus h that we see in all of ours, the plus k and the a. So in our parent, we will always cross the x and the y-axis at 0, 0. And if we think about some key points in this parent graph, the cube is going to affect our negative. So if I put 0 in, I get 0 out. If I put 1 in, 1 cubed is 1. If I put negative 1 in, negative 1 cubed is negative 1. If I put 2 in, 2 cubed is 8. If I put negative 2 in, negative 2 cubed is negative 8. So we start to see this behavior for quadrants 1 and 3. So 1 in, 1 out, negative 1 in, negative 1 out. Positive 2 in, 8, negative 2, negative 8. And you start to see that swoosh pattern form. So A this time still controls direction, except a positive A is going to have our direction going this way. A negative A is going to cause a reflection over the y-axis, and we're actually going to curve the other way. A is still going to control our rate of growth, and so our A that is a fraction between 0 and 1 is going to make it grow more slowly, and an A that is bigger than 1 is going to make for a faster growing graph than our parent. H controls our right and left movement, so x minus h moves us right h units. X plus h is going to move us left h units. K still controls up and down, so positive k moves us up and negative k moves us down. So go ahead and tune into the next video for the examples.